Welcome dear students, we are on the CEC-UGC lecture and we are in the series of electronic circuit and we are discussing the printing electronics, and in this printed electronics we are discussing the substrates we are using for the printing technology. So substrates, we just keep in the some of the properties in mind whenever we select the substrate, like physical properties, like its thermal properties, like other properties we will keep in mind whenever we select the substrate. Now the another important point whenever we select the substrate is the compatibility with the ink. So now further we will discuss compatibility between the printable material and the substrates. So most of the polymers have low surface energy. So the transfer and the distribution of the ink on the substrates depend on the wettability and the adhesion capabilities, like how the ink are compatible with the substrate depends upon the substrate's wettability, means it's the porosity, moreover adhesion, how we just it will be absorbed on the surface of the substrate. So the adhesion between the two materials is the sum of the number of the mechanical, physical and chemical force between them and at the interface, and depend on the mechanism of the adhesion involved and include the many substrate properties like chemical composition, surface topography and porosity. So substrates property must satisfy these points whenever we select the ink according to the substrate. So conductive ink properties, which is having a chemical composition, rheological behavior and the rate of solvent evaporation, the substrate must be used accordingly. So the superficial tension, that is ST of the ink, and the SE, surface energy of the substrate, that will receive the ink, that is the difference between them, we will define the parameter. So functional group and their intermolecular forces present in the polymer system. You see on the screen that we are having the three type of the surface, which is having a low surface tension, second is the medium surface tension and third is the high surface tension. And you see whenever a drop, you can see the position of the drop in three surfaces. So surface, wettability, spreadability and the adhesion are the most important requirement in the printing process, and both are directly depend on the fluid contact angle. So the drop that is act as the ink and the which is on the substrate will be depend upon the wettability, spreadability as well the adhesion. Moreover, when the fluid spread evenly over the surface without formation of the droplet, the surface is said to be wettable. So the first condition is the wettable condition, and it is possible in the low surface tension. When a droplet is formed, the surface is said to be non-wettable. So implying that cohesive forces associated with the fluid are greater than that of the forces associated with the interaction of the fluid with the surface. So surface tension refers to the amount of cohesive forces between the fluid molecules. We describe the degree of the energy with which the molecules of the surface of a solid draw and allow adhesion of the fluid. So often ST and SC are interrelated, since both measure the ability of molecules to attract and to adhere of the each other, means both the points must in the contact. Moreover, the surface tension accordingly, so that the ink must not spread at the surface and it work as the droplet. So in IPT, the shape of the fluid emerging from the nozzle is defined by the ST of the liquid. It must be in the form of the droplet. It must not spread on the surface. If it is spread, then the surface will not be draw. Then the surface at the surface, the circuit will not be draw accordingly. So the surface must be having the property of the surface height surface tension. So adhesion between the two surfaces ink and substrates occur when these droplets come into the contact and develop the strength in order to maintain a stable interface between the solid and the liquid. As we having the ink in the form of the liquid and substrate in the form of the solid. So their contact between the solid and liquid must be in the form of the surface tension defined. So adhesion between the solid and liquid exhibits when the solid surface energy exceeds the liquid surface tension. So in the polymer, low surface energy represent a greater challenge in the printing electronics. So the surface treatment are required to increase the surface energy of the polymer, although it implies an extra step in manufacturing process, increase the time and cost of the production. But the increasing of the surface energy is primary requirement in the polymer substrate. So adhesion in enhancing the techniques such as chemical as well as the mechanical, which induce the roughness of the surface and restoring the primer, that will be the frame treatment. And some example we are having, like the most common technique we use the plasma flame, the chemical treatment. In the plasma and the flame treatment, the substrate surface energy is changed by creating the functional group on the surface and eliminating the surface contaminants. That's why that the surface treatment is temporary. The treatment, enhancement and compatibility of the surface with the ink accordingly done by the chemical treatment or after the surface treatment, and both the options are possible. In case of the surface treatment, the surface characteristics will change, like physical and chemical characteristics, by increasing the total area of the interface between both the layers, leading the structural changes that must be the interaction between the fluid molecules and the substrates. For this, we have to increase the interface of roughness of the substrates. Different type of printing electronic devices require the different properties, in which we have the some of the properties, which is flexibility, high transmittance, low surface roughness, lightweight, low thermal expansion, stiffness, heat resistance, low cost and the low thickness. These are the parameters whenever we select the substrates for the printing electronics. So the print quality is affected by the surface roughness and the porosity of the substrate. So whenever we talk about the surface roughness and the porosity, that must affect the printing of the circuit. So high porosity and the large surface roughness can cause the disconnection. Moreover, the spreading of the ink and the non-uniform conductive patterns due to the ink penetration. So whenever we draw it, we can get the distorted structure on the substrate. So the disconnection of the conductive particles cause a decrease in the conductivity, and the device will not work properly. Means we are having a distorted circuit somewhere in the circuitry. So this can be avoided by using a coating for a substrate, increasing the amount of conductive ink used or the printing wider patterns. Additionally, the surface roughness has a contingent impact on the conductivity of the printed pattern. And these surface roughness can be measured by using the surface topology and the cross section of the sample. For this, AFM and scanning electron microscopy can be used for the surface topography. So, SAM can additionally be used for study the cross section of the sample, as we can just, if we prepare the polymers in the laboratory, then we have to do the SAM so that we can get the surface roughness, surface energy by using the SAM or AFM. Now, the porosity can be examined using the print penetration test or the mercury porosimeter. By using that, we can measure the porosity of the substrate. Moreover, the flexible substrates is a thin, we can measure the thickness of the substrate. Moreover, we are having a heat resistance material that is typically made of the polymers like polyamide and the polyethylene. So, PET we can take it as the substrate which is flexible, and in many of today's computing and electronic devices you can you can see the thin PCBs that transmit the signal between the control, prompt and screens are often made of the flexible substrate. So, day by day this is increasing, day by day this market is going to be increased, so that we can prepare the flexible and wearable devices if we select the substrate accordingly. So, this technology is often used to create the wearable devices, flexible display and the sensors that can be integrated into the cloth and the medical devices and for the other products. So, for this for printing electronics we can use the paper, we can use the fabric, we can use the plastic as the flexible substrates. So, the manufacturing process of the flexible electronics involve the use of the specialized material and techniques that allow for the creation of the thin, lightweight, flexible components. So that it can be shaped, it can be bent, it can be twisted without damaging the device and affecting its performance. So, nowadays the sensors are prepared on the flexible substrate. So, what are the advantages of the flexible electronics? Manufacturing. In the flexible electronics manufacturing, often several advantages we have. Traditional electronics has been changed into the advanced electronics, in which we are having the flexible devices and whose shape and which can be shaped as well as molded to fit the variety of the form of the factors, like making them ideal for use in the wearable devices, medical devices and other products where the flexibility is important. Another point is the lightweight. The flexible electronics are often much lighter than that of the traditional electronics, making the idea, because the substrate which we are using are of having the lightweight. So, the device which you are preparing will be the lightweight, as we are using the ink also. So, we are preparing the device by using the printing technology. We print on the substrate by using the ink, making them ideal use for the product where the weight is concerned. Moreover, the durability. Flexible electronics are often more durable than that of the traditional electronics, as they are less likely to break or crack when subjected to the stress and impact. Low cost, as well as you see that the cost of the paper, cost of the PET is very less as compared to the other substrates. So, flexible electronics can often be produced at a lower cost than that of the traditional electronics, as they require the less material and can be manufactured using the simple process. If we talk about the overall performance of the flexible electronics, it is nowadays these are rapidly growing and has the potential to interact with the electronic devices in a faster manner and in a shorter time as the technology continues to evolve. So, the innovations are also required in this field. Innovation in the form of the substrates we are using, innovation in the form of the ink we are using for printing electronics. So, materials used for the flexible electronics, in which we have discussed previously that there were various conductive and other type of ink insulating inks, semiconductor ink we used in the previous lectures, that how we will use the different type of the substrates, different type of ink we have used. So now what technology we use in the flexible electronics? So flexible electronics manufacturing is rapidly growing industry, and it involves the production of the electronic devices which can be twist, bend and folded. So it is a very great challenge just to prepare the device which is flexible and stretchable. So how we prepare the devices, as we have already discussed, the printing technology and deposition techniques that are used for printing the devices on the flexible substrates, and that's why it is a flexible electronics. So printing technology which is commonly used in the flexible electronic manufacturings are cost effective, and it is a scalable solution for producing the flexible electronic devices, and in which we have discussed the inkjet printing, screen printing, flexographic printing, deposition techniques. In the deposition techniques we have discussed the physical vapor deposition, chemical vapor deposition, atomic layer deposition, and many more type of many type of the preparation techniques we have defined in the previous lectures. Now we define the flexible PCBs and how many types of these flexible PCB. Flexible PCB, again I repeat this, that it can be foldable, it can be molded, it can be used in the wearable devices. So these are the flexible PCBs. Now how many types of flexible PCB? Would categorize in the various type: rubber like substrate, and which is with the copper conducting traces components, sensors on it. So these are the single sided flexible PCB. Second is the double side flexible PCB, third is a multi-layer flexible PCB, and four is the rigid flexible PCB, which is a combination of the rigid flexible, which is a combination of the rigid as well as the flexible substrate. So if we understand the structure of the flexible PCB, it is constructed from the layer of the material used to conduct, insulate or bond, like based on the number of conducting layer. FPC means flexible PC printing components can be divided into the single, double and the multi-layer. So so we can define it as the various type of layers. So important feature of the flexible PC are area where the outside cover layer of the insulating material is removed to expose solder pads and the copper plate holes, that is called the vias, and that is used for conduct between the layers. You can see that this is the shown here, that we are having a polyamide, moreover we are having a adhesive, we are having a copper, and repeatedly we can just prepare the layer of that, and you left hand side there is a white. So in the single layer configuration, which consists of the flexible dielectric substrate, adhesive layer, conducting layer and another adhesive layer, and a flexible dielectric cover layer. So this is a single layer configuration, so which use these type of layers, and then we prepare the substrate. Another is a double layer configuration, which is having a stack of the adhesive, conductor, adhesive and dielectric on both the side of the base dielectric. So plated through hole serving as a vias are added to connect the conducting layer. So conducting layer are connected both the side. So this is the double layer configuration. Another is a multi-layer configuration, that is also a multi-layer configuration stack. This laminate structure with a many layers as we require, and the vias can be done through or the blind. So this is the multi-layer. Now we just see the flexible PCB that can also be attached to the rigid PCB by embedded layer inside the rigid PCB. So these are the type of the flexible PCB. So, in the configuration which is called the rigid flex PCB is often way to take the advantage of each format at the same time, or connect the multiple rigid PCBs with the flex circuit instead of the wires and the wire harness. So, advantage of the flexible PCB also make them a good match for design that use high density interconnection and which allow engineers to create the rigid flex PCB with the more compact circuitry, thinner layers and micro wires, all while having a flexible portion in the PCB design. Moreover, the smaller form of the factor makes the HDIs stronger choice for the application with the complex and tight packaging needs. So the tight packaging make the flexible PCB not just the preferable choice to offer greater design options, but often the only way to connect HDC with the other components. Moreover, another layer is the flexible dielectric layer that we will keep in between that, and this is the base material of the flexible PCB, and it defines the characteristics and the physical property of the assembly, especially for the shape and the rigidity of the final structure. So, substrates usually made of polymer because of its flexibility, resistance to the chemical and advantageous for the thermal properties. So, this is the another type of layer. Another type of layer is the bonding adhesive layer. That layer, this is the laminate structure uses as a adhesive layer because the conductive layer does not bond directly to the base layer. So, we use the adhesive layer. Designers should pay attention to the bonding strength and the maximum temperature of the adhesive material because of these values having a limiting mechanical and thermal properties. So, another layer is the conductive layer. So, this layer, conductive layer of the laminate stack is usually made of the copper. However, other conducting material can be used for necessary, but generally we use the copper layer, and this copper layer create from a foil, and that is bonded to the substrate and then etched to create the desired circuitry. So, metal foil can come in a variety of the thickness as well as the variety of the surface roughness. So, copper coil is usually rolled to produce the rough copper foil as well as electro deposited or electroplating conducting ink can also be used to print the traces. Another is the plated copper. So, when the design require a connection through the layer, holes are drilled through the laminate and plated with the copper to create the wires. So, another is the surface finish. After doing that, the downside of the highly conductive metals like copper is that they easily oxidize. So, the combat this a thin coating of the material is applied as a surface finish on both the side. These materials also aid solder bonding, and the most common type of surface finish are electroless, nickel, gold, organic material we can use in this case, silver and so on. The stiffness, sometimes the mechanical stiffness is required in the region of the flexible PCB. So, for this FR4 we will use for this for the thicker layer of the polymeride. So, these are the basic polymer used for the flexible circuits. So, in the type of circuits we have defined the many type of the flexible circuit. Nowadays these circuits are used for the development of the electronic gadget. So, in the application of the flex circuits, we are having a static application as well as we have a dynamic flexing application. So, depend upon the requirement of the product we are using. So nowadays we have to keep in mind that how we can change the advancement of the circuitry by choosing the right ink as well as by choosing the right substrate for the for the printing technology as well as for the flexible electronics as well as for the wearable electronics, so that it can be used for the further application. Thank you very much.